Hi everyone, welcome back to my channel Tech Lab. Today we are diving deep into binary search, one of the most fundamental and powerful algorithms in computer science. If you have ever wondered how search engines, databases, and competitive programmers quickly find data, this is the video for you. Stick around because we'll break it down step by step with clear visuals and real-world applications. So let's get started. So what exactly is binary search? It's a searching algorithm that follows a divide and conquer approach. Instead of scanning every element like linear search, binary search divides the search space in half repeatedly. This makes it incredibly efficient with a time complexity of all log n. Example: imagine looking for a word in a dictionary. Instead of flipping through every page, you open the page in the middle and check if your word is before or after the page. That's exactly how binary search works. Why learn binary search? You might be wondering why binary search is important or why should we learn binary search. Here's why. The speed that it gives. It's way faster than linear search, especially for large data sets. Used everywhere. Database, search engine, competitive programming, and even finding elements in sorted arrays. Interview. Many companies like Google, Amazon, Microsoft love binary search problems in their interviews. Now let's see how to break down the algorithm step by step. That means how to do the search in search binary search. First step, ensure the array is sorted. Second, set two pointers low at the beginning and high at the end of the array. So low is index 0 of the array and high will be index n, which is the last index of the array. Step 3. Find the middle element using the formula. Mid equals low plus high divided by 2. Step 4. Compare the middle element with the target. If it matches, return to the index. If it's smaller, move to lower to mid plus 1. Search in the right half of the array. If it's larger, move to high plus high to mid minus 1. Search the left half of the array. Step 5. Repeat until the target is found or low exceeds high. How can the binary search be implemented in two ways, iterative and recursive? Let's compare them. Iterative binary search uses a loop to repeatedly adjust low and high, more memory efficient as it avoids recursion overheat. Generally preferred for larger data sets. Recursive binary search codes itself with updated search ranges, more readable and concise. Use extra memory due to function or stack and can lead to stack overflow. Use large arrays. Which one to choose? If memory usage is a concern, go iterative. If you prefer cleaner code and can handle recursion depth, go recursive. First, let's see a code implementation for iterative approach. You can try this out. So, this is the code implementation for recursive approach. If you have any questions related to the code, please comment below. So, if I just explained the iterative approach approach called. Firstly, there are two parameters which gives the array and the target that we find. So we have put variable low, high, and then we are going in for a while loop, which has its loop to find the target and also to see if the target is greater or lower. Then in the recursive approach, there are three parameters, which first parameter gives the array, secondly the low, and third high, then the target which we need to find. So firstly we use the if method to find the low is greater than high or not. This shows whether the array is empty or array has something. If the array is empty, it will return -1. If it's not, it will continue with the process or the method. Next, the mid is calculated, and again we have a if method where we see if the mid is equal to the target. If it is, then we will be returning the mid as the answer. If it's not, it will follow with the else if loop. So then we see if the mid is more than the target, and then we go repeatedly until we find the target. Now, let's see the next slide. Even experienced coders make mistakes in binary search. Here are some common ones and how to fix them. Forgetting to sort the array. Always ensure the array is sorted before applying binary search. Wrong middle index calculation. Not handling edge cases accounts for empty arrays and cases where the target isn't counted. Infinity loop in iterative search. Always update low and high correctly. Stack overflow in recursion. Use iterative binary search for larger arrays. Here are some real-world applications where we use binary search, such as searching in large datasets, database indexing, algorithmic problems, and etc. There are advantages and disadvantages in using binary search. So advantages are highly efficient for large datasets, algorithmic time complexity significantly faster than linear search, versatile, applicable for various search scenarios. Disadvantages requires a sorted input array, which may add overheat, not suitable for unsorted data, and data that is difficult to sort, can be less efficient for very small arrays where the overheat of sorting may outweigh the benefit of binary search. So we have come to the end of the session. So we learned about binary search and how we can use it in real life. Also, what are the usefulness of binary search, advantages, disadvantages, the code implementation for iterative approach and recursion approach. So the next step for you guys is to practice problem in lead code, gives for gigs, or code forces, and try them out. If you find this video helpful, smash the like button and subscribe for more. And drop a comment if you have any questions. Until next time, happy engineering.